Good morning, boys and girls. Um, now we're going back to our learning through the recording. So here we go, 5.4. And we talk about equations. And there's two types of equations, exponential and logarithmic. We have done this one here before. This is, again, is a solving, right? So solving for x. So by self-evident truth, if a to the power of x equals to a to the power of y, if the base is the same for exponential functions, then if and only if x has to be equal to y. All right. Now, by the same token, if it's a logarithmic functions, then if the base log base a of x and the same log base a of y, if they're equal, then if and only if x has to equal to y. Now here, because of this restrictions or conditions that we discussed before, you have to check the solution whether or not that fulfill these conditions. And if it does not, and then this be considered extraneous roots and then rejected. All right. Now in the textbook, there are 8 examples. Now this time I do not demonstrate the examples here. You can absolutely read through them, practice along them, and then you will be perfectly fine. So now, through all the examples, then we can see in this section, as a matter of fact, there's 2 abilities that by expectation that you should develop at the end. As far as I'm concerned, the ability is to apply the rule. So it's absolutely application to apply the rule. What rule? It's the rules of logarithm. The rules of the logarithms. All right, so that's one thing. Now the second thing is that also you needed to be fluently switch. This is absolutely switch between the exponential function and the logarithmic function. So that's basically the 2 things that are expected. So I am going to just demonstrate a number of questions in the exercise set. Now here says solve for x. And here this reminds you that reject the roots, right? Excuse me. Some of the questions they will not say, this is a solve for x. Then you have to develop this habit of check and reject. Now, I'd like to demonstrate this example. Okay. Now here you got a number 1/2, and you got this 2 log. I'm very, very thankful that they're the same base. All right. So then in this case, there are 2 ways of doing it. So one way of doing it is that, okay, I wanted to this side become log the base 16 of something, and then this side is also log base 16 of some other things. So then this one will equal to that one in order to solve. So then what am I going to do with the number 1/2? So, well, that's what I'm going to do. Number 1/2, that equals to log base 16 to the 16th to the power of 1/2, right? So then that means that becomes log base 16 of 4. Okay, so now on this side, I'm just going to use quotient rule, and that becomes log base of 16, 4 divided by x minus 3. Well, because this is a division here, right? So division becomes sorry, this subtraction here becomes division. And then over here, and then that is log the base 16 of x. All right, so now I got this equation here, and this looks like a rational equation, but it turned out to be a quadratic equation, right? So then in this case, 4 over x subtract 3 equals to x. And you're going to multiply this over there, and then you got a quadratic equation. Okay, so I'm not, for saving time, I won't do that. And then in the end, you will got the two solutions, x equals to 4 and x equals to -1. All right, now x equals to -1, that becomes a -4. So therefore, this has to be rejected because x minus 3 has to be larger than 0. So then this got rejected. So this is one way to do this, but I'm going to demonstrate another way to do it. So another way I'm just use this space here. Another way is that I can just move this log base 16 of x subtract 3 to the other side. So leave the 1 over 2 on just one side. So then that means log base 16 x plus log base 16 x minus 3. Subtraction where there's a negative becomes a positive, and then that equals to 1 over 2. And then here again, I use the product rule. So that means log base 16 x of x, x subtract 3. This whole thing equals to that. Okay, then in this case, then I can use, I can change the logarithm to exponent. Okay, so then base 16 to the power of, because this is the exponent, equals to x multiplied by x subtract 3. And then you will know this is equals to 4. So then this is a quadratic equation again, right? So this is exactly the same thing. Perhaps this is easier rather than thinking, oh, I should change 1 over 2 to that. But either way, depends on what you prefer. Okay, so now another question I'm thinking of demonstrate, but that's the same thing, you see? This is a 2. So in this case, the 2 is already on this side. So don't even worry about it. Just directly change this. This means log base 2 x to the power of 2 subtract log base 2 this that equals to 2. Okay, well that equals to 2, then that means this one could be log, use a rule, base 2 x plus 2 power of 2 divided by 3x, that equals to 2. Now the same thing, use the base of 2 to the power of 2 equals to this whole bunch. And then after you do your algebraic calculation or manipulation, it becomes quadratic equation again, right? So this means x to the power of 2 plus 4x plus 4 over that. Okay, move this to the other way to multiply. Organize it. Again, quadratic equation. Okay, now here, this is x equals to 2, x equals to 6, and they both are fine. I got to stop here for a second. So there's